You're going to use this the rest of this year. Factor in the greatest common factor. You'll be using greatest common factor the rest of this year. You'll use it next year, the year after. Any math class you take from here on out, you'll work with factoring the GCF. Where did I get GCF from? Greatest common factor. So, not denominator. GCF. So from now on, when you hear me say GCF, you know I am talking about what?
The greatest common factor.
Greatest common factor. Okay, we're ready? Part 1, actually, I'm not going to do a part 1. I'm just going to work backwards. Okay, so when you see factor, factoring, factor, know you're working backwards. Do you guys remember from yesterday's lesson I kept saying tomorrow we're going to be working backwards? That I would give you this and you'd come up with that? I'd give you the answer, you'd come up with the original problem. Do you remember when I told you that? This first piece here is what we're doing, working backwards for these type of problems. So, what we're going to do is we're going to work forward first and then discuss ways to work backwards. Okay, number 1, I'm going to work forwards first. We're going to multiply. 6x squared times 5x plus 3. That one's reviewed from yesterday, so do that now. Do your distribution, your distributive property, and get your answer, and then check it with the person sitting next to you. All right, you ready? Okay, so we go through and we distribute. We multiply the coefficients, we've been saying that. What's 6 times 5? And then add the exponents. What's x squared times x? Okay, and then again, we do it again. Is that you?
Yeah.
Can you turn it off?
Yeah.
All right. Plus 6 times 3 is positive 18, and the x stays x squared because of x squared there. All right. Questions? So, 30 x to the third plus 18x squared. All right, so here's what we're going to do. I am going to give you number 2, which is going backwards. And what is it called going backwards? Factor. Factor out a GCF. 30x cubed plus 18x squared. Now, just write it down and then put your pencils down, and I want to explain some things. Just write it down and then put your pencils down. Write it down, pencils down. Okay, we're ready? Should we know the answer to this problem without any work? Why? Because I told you we're working backwards. I'm giving you the answer. You work back to the original problem. Is this the answer we just got on number 1? So working backwards is going to be what? What's going to be the answer to this? The 6x squared parentheses 5x plus 3. Okay. So the answer to factoring this is this up here, because again, we're going backwards. What I want you to do right now on your own, I'm going to give you a few seconds to a minute, is try it on your own to figure out how to get from this to this. If I give you this problem, how to get this as your answer. And then see if you would be able to explain it to another person. So try it now. So you're trying to figure out, we know the answer, how do you get that on your own? Okay, so quiet time first. Quiet time first. Quiet time first.
Yeah, really good. Small division. No?
It's only one sheet tonight.
Oh, yeah.
I submit these here, so. All right. Okay. Anybody get it that can explain to, oh, actually before I have you explain, talk to each other and see what tools you came up with. If you had explained this, tutor this to someone, how would you explain how to get from here to here?
So you find like the greatest common factor between those things, which 6 goes into 30 and 18.
Were you my
Why do we have to factor? Factoring is a huge part in mathematics. That's the factoring. Typically this used to be taught in middle school. And kids would do it in middle school, in 9th grade, in 10th grade, in 11th grade, and 12th. They would do it years ago because it's used so much. It's used in higher level math.
Maybe I have
When you're graphing problems to find solutions, to find zeros, to find x-intercepts. When businesses are trying to make money, when they're selling items, and they want to know when. Isn't that Jaden again?
No, that wasn't me.
Whose cell phone?
Nathan does.
You figured it out?
What?
Okay, so when people are selling,
I turned mine off.
let's see what else I can say.
Candy?
No, that
People
was
are trying to sell items and they're making money off of it, and they want to know at what point do I break even? You would work faster. There's a number of instances where you would. Okay, Sal, you're going to explain it. You said, okay, I can do it. Go. Shh, we're listening.
So Kelly's brilliant mind told me that 18 and 30 can be divided by 6.
Okay, so what goes into 18 and 30? The biggest number is 6. Now, as I was listening to you guys talk, I heard somebody say greatest common factor. Yes? Yes. Nate said, find the greatest common factor of 30 and 18, and that is 6. Do you guys agree?
Yeah.
Okay. Good, good, good. Keep going.
And then I put x squared on it.
Okay, why? Okay, there's an x cubed and there's an x squared. Why the x squared?
Because, like in the other problems, there's a regular number, like without any exponent. So,
Oh, right here? Oh, okay, okay. So he's saying here there's a number with no exponent, so this must be the x squared to make that the x squared here. Is that what you're saying? Okay. And then parentheses, okay, keep going.
So, I divided 30
Mm-hmm.
by 6.
Okay, so you divided 30 by 6 and got 5. And let's make the x squared. And what do you do when you're dividing exponents? Do you add or subtract? Do you guys remember that? No, we don't remember that? Subtract. 3 take away 2 is 1. Okay, I typically don't show it that way with dividing the x squared. I do with the 6. Okay, so he said divide by 6 and get the 5, and I jumped in and talked about the x. Tell me how you got it.
Because there's 3 in there. X and 3
Okay, so that's how I do it. He said there's a cubed here and a squared here, and 2 plus what is 3? That would have to be x to the first to make it to the third. Okay, keep going.
And then I divided 18x squared by 6x squared, and I got 3.
3. All right, so he divided them all by 6x squared and got 5x to the first plus 3. And is that what we started with? Do you have to write the first power here? Not necessary. If you do, that's perfectly fine. Thank you, Sal, for explaining. Yes?
Couldn't you just say that you could put the 5x squared and then just 6x? Couldn't you do that?
Oh, good question. Okay, let's talk about that. I do have a note here to make 2 different types of mistakes kids make. Okay, so let's talk about mistakes and why they are mistakes. Okay.
It won't give us what we have to make it into. So.
Okay, so first off, there's a few things you have to check to make sure this is the right answer. First, most important, when you distribute, do you end up with the original problem? Let's check. 6x squared times 5x, is that 30x cubed? Yes or no?
Yeah.
6x squared times 3, is that 18x squared? Yes? Okay, second thing you have to remember to check. Is there still a GCF? Is there still a greatest common factor? Does 5x and 3 have any common factors besides 1? No. There are no common factors. There are common multiples, but no common factors. So this is the final answer. Because it's called the greatest common factor, whatever you pull out has to be the greatest. For example, if a kid did this, took out the 6 but only made this an x, means that this is 5x squared plus 3x. Let's test this. Is 6 times 5, 30? Is x times x squared x cubed? Is 6 times 3, 18? And x times x, x squared. Then why is this wrong? If I distribute, like I said, and I get the original answer, the original problem, why is this wrong? Because there's still a what in here? There's still a common factor. Good job. Still a common factor. Now, there's how many things are you supposed to check here, did I say? 2. 1, not only does it distribute to give you the original problem, but also that there's no more common factors. If there is, this is not the right answer. Now, I often have kids say, well, I checked it like you said and I distributed. Yes, but is that the only thing you're supposed to check? No. What else do you check for? You look to see if there's still a common factor. And I'm going to show you another mistake kids make. Before I do, I'll answer your question.
Can you write down the steps to get the correct answer?
Yeah, I'm going to do that in the next one. I'm going to go through and explain and da-da-da. Okay. Another mistake kids make is they look at 30 and 18 and they think, 3 goes into both of them. Does 3 go into 30 and 18? And then they say x squared. 3 times what is 30? 10. X squared times what is x cubed? X, yes or no?
Yeah.
Plus 3x squared times what is 18x squared? 6. Now, does that work? When I distribute 3x squared times 10x, does that give me 30x cubed?
Yes.
3x squared times 6, does that give me 18x squared?
Yeah.
Okay. Why is this one wrong? Because I would mark this wrong if you gave me this. Right, you look in here, is there still a common factor? What is it? What still goes into 10 and 6? 2. Do you guys see that? Okay, so when you're doing these problems, what 2 things do you look for? 1, does it distribute to the original problem? And 2, is there still a what inside? Is there still a common factor? If there is, this is not the right answer. Let me give you a quick hint here, and this is just a trick to use. Most kids mess up right here. They get this number that's too small. When you look here, what's still the common factor between 10 and 6? So pull a 2 out. What's 3 times 2? And 6 x squared would be your greatest common factor. Okay, so that's a little trick to use. All right, so let's try another one. We're going to discuss the steps and how to do it. Well, actually, let's discuss the steps on here. What was the word that Nate used earlier? Find the greatest common factor between 30 and 18. Yes? And what was the greatest common factor? 6. All right, so step 1, find the greatest common factor. Find the greatest common factor of the coefficients. Step 2, what do we use for the x's? X cubed, x squared, I pulled out an x squared. What is it going to be, the larger exponent or the smaller exponent? Smaller. But it's called greatest? Is that what you're going to say?
I don't know. Wouldn't that not always be true though?
It will always be true. We'll do a few and see. All right, these steps right here are just how to find the GCF, how to find this guy on the outside, and we'll talk about how to work backwards from there. Okay, so this is how to find the greatest common factor that you're going to write out here. First, you find the greatest common factor of your coefficients, and then you take your smaller of your exponents. Now, kids often say, why the smaller if it's called the greatest common? Do you agree if there's 3 x's here and 2 of them here, how many do they have in common? There's 3 here, there's 2 here. How many do they have in common? 2. So the smaller exponent will always be the greatest amount that they have in common. Does that make sense? Yes?
Yeah.
All right, so let's try one. Number 3. 6y cubed minus 6. I do this one because it's super easy, but kids always miss it. All right. First, find the greatest common factor of your coefficients. What are my 2 coefficients here? 6 and
6.
what's the greatest common factor? 6. Then you take your smaller exponent, y cubed, and no y at all. If there's no y, will I have a y as part of my greatest common factor? No. No, so it is just 6. Now that freaks people out sometimes. You will not always have a variable coming out, or sometimes it's just a variable and no coefficient. Sometimes it's both. It all depends on the problem. Can anybody explain why it's just 6 and not 6y or y squared? Yes?
Because the y has to be cubed on the inside for -6 to work.
Okay, so why can't I put 6y or y cubed out here? Because this guy at the end does not,
Doesn't have a variable.
it doesn't have a variable. Do you see that? If any one of your terms does not have a matching variable to what you're pulling out, then you're not going to put that as part of your GCF. All right, and now we work backwards. 6 times what is 6? 6 times what is 6? 1. And then y cubed. Why y cubed? Because I need the y cubed there. Take away 6 times what is 6? 1. Now, is this 1 needed right here? Is this coefficient of y cubed? It is not. Is that 1 needed right here, the -1? That one is. So if you dropped this one over here, you would be okay. If you dropped the one at the end, you would not be okay. This one at the end, you need one. I'll explain a little more.
Because the -6 doesn't have to.
All right. A few things you need to recognize. How many terms, we talked about terms yesterday. How many terms do I have in my original problem? 2. When you factor and you look inside your parentheses, you should still have how many terms? 2. And do I have 2 terms? A lot of kids forget the 1 and they just put y cubed. No. If there are 2 terms here, there should be 2 terms here with your GCF on the outside. Okay, what are the 2 ways that we check? Distribute. Let's do that first. What's 6 times y cubed? 6 times 1 or -1? And is there still a GCF? Is there still a GCF in here? No. This actually is still factorable. You'll learn that one next year. Y cubed minus 1. But for now, we are done. All right. 63x plus 45. Will there be an x coming out on this one? Will x be part of our GCF on this one? Why not? Why will x not be part of? Because 45 does not have an x. All right, 63, 45, what goes into both 63 and 45? 9. So will you need to know your factors on these? Yeah, or you can start to break down and see what goes into 63, what goes into 45. 9. Now, 9x or just 9?
Just 9.
Why just 9 and not a 9x? Because 45 does not have an x. And in order for it to be a GCF, it needs to be common with all, and it is not. I'm going to let you finish it from here. How many terms did I start with?
2.
So how many terms should be in my parentheses? 1, 2. And with the plus sign in the middle. Go ahead and finish it off. Okay, are we ready? Okay. Tara, can you tell me what you have left inside here?
9 times 7, so 7. 7x to the first power.
Uh-huh.
And then 5x to the first power.
Okay, if I put a 5x here, this is telling me that 9 times 5x is 45.
Yeah.
Is that true?
Oh, no, it's just 5.
It's just 5. Good job. All right, guys, please stop. Are you paying attention? Okay. Now, Tara said initially x, and then she said, oh, wait, never mind. You guys understand why there's no x here. Okay. So let's look for GCF first, because it saves us time that way. Is there still a GCF here? No. What else do I check? That it does what?
It is 2 terms.
That it distributes and has 2 terms. Okay, what's 9 times 7x?
63.
9 times positive 5?
45.
Did it work?
Yes.
Okay. So right now we're just learning our basic skills. We will be using factoring to solve problems in the future. Okay, number 5. 5p to the third plus 12p squared minus 18p. 5p to the third plus 12p squared minus 18p. How many terms are there here? 3. When I factor, there should be 3 terms inside my parentheses. All right, look at your 5, your 12, and your 18. Is there a common factor? Does any number besides 1 goes into 5, 12, and 18? No. Now kids will say, well, over here, 12 and 18, I can get 6 going into both of those. Is 6 my GCF? No, because 6 does not go into 5. Do you see that? Now, does that mean there's no GCF?
No.
What have I not checked yet? Variables. So I have a p cubed, a p squared, and a p to the first. Which one did we say earlier we pull out? The largest or the smallest? Because the smallest is the max amount that they have in common. So p to the first power is the only thing that comes out. If you put a 1 here in the front, is that okay?
Yeah.
Not necessary, but it is okay. Okay. 3 terms plus blank minus blank. Okay, p to the first times what is 5p cubed?
5p.
5p. Now I heard a few of you say 5p squared. How did you guys get that?
1 plus 2 is 3.
Because 1 plus 2 is 3. Okay, p to the first times what is 12p squared? 12p. I need you guys paying attention. Okay. Why? Because 1 times 12 is 12, and p1 is p squared. Minus p to the first times what is 18p to the first? 18p or just 18? Can anybody tell me if I put this here how I could tell that's wrong? Where would I find that as a mistake?
Because it's dp squared.
With
P1
Right.
plus P1 is P squared.
She's saying that there. I heard two people say it. When I distribute here, I would get 18p squared. And is this 18p squared? Okay, so this is just 18. All right, 3 terms. Let's distribute and check GCF. Is there a GCF between 5p squared, 12p, and 18?
No.
No. No, there is not. Okay, now I'm going to have you quickly distribute and see if it works, and we'll move on. P times 5p squared, P times 12p, and P times negative 18. Did it work? Okay. Number 6. 4t to the third minus 24t. All right, let's look at our coefficients first. Oh, how many terms do we have here? 2. So look at your coefficients. What are my 2 coefficients? 4 and what? 24. So look for your greatest common factor. What goes into 4 and 24? It's even, so we know for sure 2. And you guys say 4. 4 is bigger. Does it go into both? Okay, so for sure 4. Perfect. Good job. And what else? Any t? T coming out? Yes or no?
Yeah.
They both have a t. Will I take out t cubed or t?
T.
Because we always take the larger or smaller exponent. Smaller because the smallest one is the total amount that they have in common. You agree?
Yeah.
Okay. All right, so what is the GCF? 4t. And how many terms will I have left inside the parentheses? 2. 4t times what is 4t to the third? T squared minus 4t times what is 24t? 6 or 6t?
6.
Just 6 because 4t times 6 is 24t. And if I put a t here, what would happen?
It would be 24 squared.
It would be 24t squared, which it is not. Do you guys see that? Okay. Questions on that one? Are we good? Now, I'm going to do something that kids sometimes make a mistake doing, and I'm going to have you look at it and on your own, think about what is the mistake, and be able to explain how to find it. Okay, so I'm looking at this. What's in common between both of them? I can tell that 4 goes into it, and 4 times t to the third is 4t to the third, minus 4 times 6t is 24t. When I distribute like my teacher said, I distribute and I get 4t cubed. Good job. I distribute, I get negative 24t. Good job. So this is my right answer. Turn it in and I get it wrong. Now, don't do any talking. I just want you thinking about what is a mistake, where did I mess up, and how can you find that on your own? When you're doing this, how could you tell that there is a mistake that's been made? I'm telling you right now, but how would you know on your own? So you're thinking. This one here. I messed up. I'm telling you there is a mistake. So you're trying to figure out what is the mistake and how do you know when you're doing this on your own that a mistake has been made? Okay? Talk to the person sitting next to you and explain to them. One's going to explain the mistake. The other's going to explain how you can tell a mistake has been made.
It's supposed to be 2 variables.
Are you talking?
And no variable.
Yeah.
It looks like he's talking.
I'm listening.
Okay.
I'm listening to him and his ideas.
Okay, and then I'll share yours.
And
Yeah,
also there's various comments.
There were 2 things. All right, do we have it? Okay, a volunteer, what was the mistake? Yes.
You need a variable on the form.
Okay, it's not, my GCF is not 4, it's 4t. Okay, thank you. Is that what you were saying?
Yeah.
Okay, anyone else? How can you tell when you're doing this on your own, if you were tutoring a friend and you saw that, how could you tell that a mistake has been made when you look at this answer?
Because there's no variable on the outside.
How can you tell? When you look at this answer, how could you say, oh wait, there's still a GCF, or I just gave it to you. How can you tell there's a mistake being made? What do you look at in here?
There's the greatest common factor.
Is there still a GCF in the parentheses?
Yeah.
Yes, and if there's still a GCF in the parentheses, is this the correct answer?
No.
No. It is a mistake. Okay. Are we good? All right, number 7. Put those away. Negative 15y to the third plus 3y squared minus 27y.
Mine is 27.
Mm-hmm. Okay. Coefficients 15, 3, 27. What goes into 15, 3, and 27? 3. Do we agree? Yeah. Y cubed, y squared, and y. What goes into y cubed, y squared, and y? Or which one do I take out? The largest exponent or the smallest? So 3y. Before you go any further, put your brakes on. Just wait 1 second. I will tell you this. When you're factoring GCFs and your leading coefficient is negative, your greatest common factor we typically make negative. We pull out a negative when your leading coefficient is negative. Leading coefficient means the coefficient in the front, the one that's the lead. The leading coefficient, if it's negative, our greatest common factor is going to be negative. We pull out a negative to make this in here a positive leading coefficient. Okay, so let's talk about this. Negative 3 times what is negative 15? Positive or negative 5? A negative times a negative would be a positive. Do you agree negative 3 times positive 5 is negative 15?
5y squared.
And then can you tell me how you got y squared?
Because 1 plus 2 is the
The 1 plus 2 is the 3? Okay, I'm trying to get 3. Is it going to be plus 1 or minus 1?
minus 1.
Yes.
Why minus 1? Because negative 3 times negative 1 is
Positive.
positive 3. And is there a y, yes or no? Y to the first or y to the second?
Y to the first.
Because 1 plus 1 is 2. Okay, negative 3 times what is negative 27? Plus or minus? Positive 9. A y or no y? No y because it's y1, y1. And this here is my answer. Now, what do we notice? A negative became positive, this positive became negative, and this negative became positive. Why did all these signs flip-flop? Why did they all change? Because we pulled out a... So whenever you pull out a negative, which you will do when the leading coefficient is negative, will all the signs in here change? Yes, the leading guy became positive, the second term became negative, and the last term became positive. Because when we factor, we like this guy in here to have a leading coefficient that's positive. Because if there's anything further to factor, you want, when you continue to factor, you want the leading guy to be positive. Okay, let's quickly check 3 terms and 3 terms, yes or no?
Yep.
Okay, distribute negative 3 times positive 5, is that negative 15? Y and y squared, is that y cubed? Okay, negative 3, negative 1 is positive 3.
Yeah.
Y and y, is that y squared? Negative 3y and 9, is that negative 27y?
Yeah.
Next thing, we check if there's any what inside?
GCF.
Greatest common factor. Is there a GCF? So this here is my beautiful answer. Okay, I'm going to have you try this next one on your own. Negative 7y to the fourth minus 21y to the third plus 7y squared. I'm going to have you first find your GCF. Don't go any further, just first find your GCF. Oh, is it going to be positive or negative? How can we tell it's going to be negative? What is this guy called? The leading coefficient. The leading coefficient's negative. Okay, so you're giving me the answer. Write it down and then check with the people around you first. So that's enough time. So check with the people around you right now before you go further and see if you guys agree on the greatest common factor. Is it positive or negative? What do we say?
Negative because you pull it out right there.
Thank you. Okay, Adam, can you give me the rest? Negative what? What goes into 7, 21, and 7? 7. And then what do I write down? Y to the fourth, y cubed, or y squared?
Y to the fourth.
We take the larger one.
Y squared.
We find the smallest exponent. So make a note right now. Go back to this section of your notes and star it or highlight it and put your phone away. Okay, so you're coming back here. Adam, are you listening to this section of your notes? Star it, highlight it, because that's the piece right now that you weren't sure about. And then over here, it's -7. What did we decide on? Y what?
Y to this second.
Okay, and then continue. And check with the people around you. Keep working. Okay, good to work.
Wait, does it matter what exponent you use?
Yeah.
Just agree that -7 times 1. Oh, that negative, okay, and -7 y squared times 1 would be +7. And kids often forget that one for that reason. So it's like, wait, what do I put? Okay.
And that's just supposed to be 1.
This one?
No, like just 1.
Alrighty, are we ready? Okay, -7y squared. -7 times what is -7? +1 or -1? +1. Y squared, I want it to be y to the fourth, so what is this going to be? First? Squared, because 2 plus 2 is 4. Okay, this is minus, what is it going to become?
3.
Plus 3, I heard. -7 times +3 is at -21. Y squared, I want it to be y cubed. What do I put here? Y to the first, because 2 plus 1 is 3. This next piece is where kids struggle. Now, first off, is it going to be plus or minus if it's plus here? And I had a really good question. A kid asked me this. If I put a y here, because that's what I think should be there, it's not right because y squared and y is not y squared.
Put a 1.
Put a 1. And is it okay to have just a 1?
Yes.
Yes, it's necessary. Kids often say, well, there's nothing there because I took it out. It's gone. Remember, if you have 3 terms, you should still have 3 terms. Is this 1 here at the end necessary?
Yeah.
It is. I often have kids do this. And they'll say, well, I pulled it out. It's gone because I took it all out and I'm left with this. How can you tell that's wrong? How many terms?
3.
And how many terms here?
2.
2. So you know right off that is wrong. So what did the student forget? They forgot to put a -1. That's probably one of the biggest mistakes kids make on these type of problems. Hustle. All right, this next one we're going to do quickly, and I just want to talk about this one because of the big numbers. 72y to the fifth plus 18y squared. And I want to talk about how to find a GCF for numbers this big. Do you agree 72 and 18, those are big numbers?
Yes.
Okay.
Just 9.
All right, I hear somebody saying 9. Do you guys agree? Does 9 go into 18? Does 9 go into 72? Okay. 9. Y5, y squared. I would ask Adam, but he walked out. Who can give it to me? Which one? Y5 or y squared?
Y2, y squared.
Y squared because we take the largest or smallest? Smallest. Okay, parentheses. 9 times what is 72? 8. And do I have a variable here? Y to the what? Third, because 2 plus 3 is? Okay. Plus 9 times what is?
2.
18. 2. Do I have a variable here if it's y squared and y squared? Is that it right here?
Yeah.
Okay. Now let's check. Is 9 times 8 72? And y squared times y cubed, y to the fifth? Yes or no? 9y squared times 2 is that 18y squared?
Yes.
Can anybody tell me why, if you gave me this as an answer, I would still mark it wrong?
There's still a GCF.
There is still a GCF. Did anybody else see that but didn't say anything, but you noticed it when I was writing my answer? Okay, so, again, now, nobody stopped me from the get-go and said, hey, 9 is not big enough. How many of you thought it really was 9? Because 9 goes into both. Yes? I would agree. I would look and then say, oh, it's 9 because 9 goes into both. But was it really 9? Is 9 really the biggest? No. The reason I'm going over this, guys, is because I want you to remember that trick that I've shown you. What's the trick that you should know? Cover that. What still comes out of 8 and 2?
4 or 2.
What goes into 8 that also goes into 2?
2.
And what did I say you do? You take that out, and what do you do with these two numbers? Multiply them?
Yeah.
What's 9y squared times 2?
18.
So what's my true GCF? 18y squared. Okay, now, you don't have to have that trick memorized, but is it a good trick to know to help you find your GCF when there are big numbers? Yes.
Or can't you just know that 18 doesn't exist?
If you know it, yes, but nobody stopped me. You didn't stop me when I put the 9. Okay, so what I'm trying to say, yes, you should know that. But if you don't because they're really big numbers, go with the biggest you know, write it down, GCF, and you say, hey, there's still a GCF. Oh, it's 2. 9 times 2 is 18. Got it? Yes. Hustle, please. All right. 18 times what is 72? Can you guys either know it or plug it in your calculators? 4. And y squared times what is y to the 5th?
3.
Plus 18y squared times what is 18y squared?
Y. 1.
Y? Should I put a y?
No.
I'm going to put the y, and can anybody tell me how we know that would be wrong?
Because 2 plus 1 is 3.
Because 2 plus 1 is 3, and that is a y squared. So what do I put here?
1.
And is that 1 necessary?
Yes.
Yes. All right. So I'm going to cover this really quick. If you put this answer and you box it in and you did not recognize that there was an error, make a note to yourself. Look to see if there's still a GCF, because kids often forget to double check that. Look to see if there's still a GCF. If there is, this is not the correct answer and you will get it wrong. Got it? Okay, if you guys will please take out your packets.